An ancient fossilized mandible discovered in the Penghu Channel near Taiwan belonged to a male Denisovan, according to ancient protein analysis. Penghu 1 is dated to between 40,000 to 70,000 years, or 130,000 to 190,000 years old, according to trace element contents and past sea level changes, because the interglacial period from 130,000 to 70,000 years ago, the land was under the sea. Using ancient proteomic analysis, scientists extracted proteins from bone and dental enamel from the fossil and discovered 4,241 amino acid residues, 2 of which were Denisovan-specific protein variants. They also discovered a variant of a protein coded on the Y chromosome in the enamel of a tooth, indicating that the fossil belonged to a male. Furthermore, morphological analysis of the remains reveals a robust jaw structure with large molars and distinct root structures, which are consistent with traits seen in the Tibetan Denisovan specimen, implying that these traits were characteristic of the lineage and possibly sex-specific. The discovery provides direct evidence that Denisovans lived in a variety of climates, from the cold Siberian mountains to the warm, humid subtropical latitudes of Taiwan and the tropical regions of Papua and Indonesia. But just how far south did Denisovans live? In the dry lakebeds of southern Australia, the winds of time whisper secrets through ancient sands. Among the skeletal remains unearthed at Willandra Lakes and Cow Swamp lie clues that challenge our assumptions about the final chapters of an archaic human species, the Denisovans. Could it be that these mysterious hominins, neither Neanderthal nor fully Homo sapiens, survived in this isolated southern continent far longer than previously thought? Could robust, enigmatic skulls like WLH-50 and those from Cow Swamp represent the echoes of the last southern Denisovans living and interbreeding with early Aboriginal Australians as recently as 15,000 years ago? Could these ancient humans have even reached Tasmania? Once dismissed as pseudoscience by the out-of-Africa theorists, we now know that highly intelligent human species with brains very much like our own walked the planet as much as 300,000 years ago and as recently as 15,000 years. This theory, though bold, is not without evidence. The cranium known as WLH-50 was unearthed from the dry beds of Lake Garnpung in New South Wales. Dated between 16,500 and 37,400 years ago, most likely around 26,000 years, it stands out for its sheer size and archaic features. An exceptionally robust vault, a cranial capacity of 1540 cubic centimetres, prominent brow ridges, and striking similarities to earlier hominids from Indonesia, specifically the Ngandong population from Java, Indonesia, once attributed to Homo solanaeus. What makes WLH-50 so compelling is not just its morphology, but its defiance of conventional evolutionary expectations. If we accept the recent African replacement model, which claims modern humans swept the globe, replacing all archaic populations without interbreeding, then WLH-50 should resemble late Pleistocene Africans or Levantines. Yet statistical analyses have shown that WLH-50 groups most closely with the Ngandong fossils, an affinity that demands explanation. Under the multi-regional model, this makes sense. WLH-50 may represent the local continuity of archaic populations in Australasia, with Denisovan-like ancestors from Ngandong contributing directly to the Australian gene pool. This opens the door to a stunning possibility. The WLH-50 is not just a modern human with archaic traits, but a hybrid, perhaps even a hybrid Denisovan. Although DNA has not been extracted from WLH-50, the genetic evidence from living Aboriginal Australians is compelling. Studies have confirmed that Indigenous Australians carry significant amounts of Denisovan DNA, up to 5% in some individuals. The geographic concentration of this ancestry in Papua New Guinea and Australia raises an obvious question: where, when, and how did this admixture occur? Recent genetic models suggest not one but multiple Denisovan admixture events with modern humans, some occurring far later than initially believed. While Denisovans are best known from the Siberian cave that bears their name, their range appears to have stretched far south into Southeast Asia and perhaps beyond. A 2020 study proposed that Denisovans may have survived in island Southeast Asia until at least 15,000 years ago, if not later. If Denisovans were present in Sunderland or Sahul during the late Pleistocene, especially its southern regions isolated by deserts and time, could well have served as their final refuge. To understand how Denisovans could have lingered in Australia, we must consider the geography of the Ice Age. During glacial periods, sea levels dropped by over 100 metres, exposing vast land bridges and merging the islands of New Guinea, Australia and Tasmania into a single land mass known as Sahul. This supercontinent was continuous for most of the last 100,000 years, except for brief warm interglacial periods like today and the 120,000 years ago. This united landmass provided a massive, uninterrupted territory for humans and potentially Denisovans to explore and inhabit. Once in Sahul, groups could disperse across thousands of kilometres from the tropical mountains of Papua to the temperate forests of Tasmania. Gene flow with outside populations slowed dramatically, creating conditions where ancient genes and even ancient species could persist. At the southernmost tip of Sahul lies Tasmania, today separated by the Bass Strait, but connected during most of the Pleistocene. It is here that some of the earliest and most enduring archaeological evidence of human occupation in the region has been found. Caves such as Kutikina and Parmapar Methana have yielded artifacts dated to 35,000 to 40,000 years ago, including bone tools, hearths, ochre and stone implements. These ancient Tasmanians lived in glacial conditions and hunted wallabies and wombats in subalpine valleys. Their sophisticated adaptations to cold climates have long puzzled archaeologists. How did early Homo sapiens learn to survive in such marginal lands so quickly after arrival? Some researchers have speculated that Denisovans, known for their adaptation to cold, high-altitude environments, such as the Tibetan Plateau, could have contributed genes or knowledge to these pioneering Australians. If Denisovans made it to Sahul, why not all the way to its southern tip? Moreover, the morphology of ancient Tasmanian crania, though less well preserved than mainland examples, sometimes includes robust features similar to those of cow swamp and WLH50. This raises the possibility that archaic Denisovan traits and possibly populations were spread across the full extent of Sahul, including Tasmania, and persisted far longer than previously imagined. WLH50 is not alone. At Cow Swamp in Victoria, numerous skulls dated between 10,000 and 13,000 years old show similarly archaic features: thick cranial bones, low foreheads, and heavy brow ridges. These specimens, like WLH50, have been called robust in the anthropological literature, but such descriptions may be euphemisms for something more profound: ancestral traits inherited from a long-surviving archaic population. Milford Woolpoff of the University of Michigan and Alan Thorne from the Australian National University, proponents of the multi-regional hypothesis, argued that cow swamp skulls, like WLH50, display continuity with earlier Ngandong specimens. Some cow swamp crania even show sagittal keels, distinctive midline cranial ridges seen in Homo soloensis. If the Ngandong hominins were themselves Denisovans or closely related, then the anatomy of these southern Australian skulls takes on new significance. It may reflect not mere variation within Homo sapiens, but the genetic echo of another species, one that refused to disappear quietly. Australia's archaeological record now stretches back beyond 50,000 years, and all point to early and widespread human habitation of the continent. Some of the oldest remains, such as Mungo Man and Mungo Woman, have been considered gracile, yet there remains unexplained variability in the skeletal material across early Australia. The coexistence of robust and gracile individuals may reflect more than regional adaptation. Instead, it may be the physical manifestation of hybrid populations, early Homo sapiens mixing with archaic Denisovans who had survived in the Australo-Papuan archipelago. These early settlers left behind rich cultural traces, engraved stones, shell jewellery and ochre burial rites that suggest advanced cognition and symbolic behaviour. If Denisovans contributed to these populations, they may have done so not only through their genes, but through shared knowledge, helping shape the emergence of Aboriginal culture. Skeptics argue that the robust traits of WLH50 and cow swamp may result from environmental adaptation, pathology, or artificial cranial deformation. However, these explanations have largely been refuted. WLH50 shows no evidence of pathology or deformation, and its robusticity is not easily attributed to age or sex alone. Crucially, the presence of Denisovan DNA in living Aboriginal Australians provides a genetic foundation for what the bones suggest. If we accept that Denisovan ancestry is real and substantial in this region, it follows that Denisovan-like morphology should also be found in the fossil record. WLH50, the cow swamp skulls, and even early Tasmanians may be exactly that, morphological expressions of archaic introgression. The key question remains: could Denisovans have survived until 15,000 years ago in Australia? Given the age of WLH50, as young as 16,500 years, and cow swamp, 10,000 years, the possibility becomes tantalizing. If these individuals descended from populations with significant Denisovan ancestry, possibly even admixed only a few generations earlier, then Denisovans or Denisovan hybrids were still present in southern Australia well into the Holocene. Unlike Europe, where Neanderthals vanished roughly 40,000 years ago, the vast arid interior of Sahul offered a unique ecological niche. Its human populations were small, mobile, and often isolated. In such an environment, archaic genes and even lineages could linger undisturbed by external replacement. The hypothesis that WLH50, the cow swamp skulls, and even early Tasmanian archaeological sites reflect a Denisovan legacy is not mere speculation. It is grounded in both skeletal and genetic evidence. If confirmed, it would rewrite the timeline of Denisovan extinction, placing their last stronghold not in the caves of Siberia or the highlands of Tibet, but in the sun-baked plains of southern Sahul. In this view, the Aboriginal peoples of Australia are not only among the world's oldest continuous cultures, but also the living heirs of a deep, interwoven lineage that includes one of humanity's most mysterious relatives. The last Denisovans may not have vanished in obscurity. They may still be with us, their legacy etched in bone, blood, and memory. Thank you for watching and commenting. Please subscribe to the channel for more content.